Understanding Experimental Control, a guide for English learners. Hello, everyone. Welcome to our English language learning channel. Today, we're diving into a fascinating topic that often appears in scientific discussions and research studies: experimental control. Understanding this concept is not only crucial for science-related English but also enriches your vocabulary and comprehension of complex ideas. Let's unravel the mystery of experimental control together and discover why it's a cornerstone in scientific experiments. Experimental control refers to the process of keeping all variables in an experiment constant except for the one being tested. This is done to ensure that any changes observed in the experiment can be directly attributed to the variable being tested, not to external factors. Think of it as isolating the cause and effect relationship in a pure, undisturbed environment. By controlling these variables, researchers can confidently claim that any differences in the outcome are due to the manipulation of the independent variable. The significance of experimental control cannot be overstated. It's the heart of a fair test. Without it, determining the actual effects of the variable being tested would be impossible. This control ensures accuracy in the results, eliminates or minimizes external influences that could skew the data, boosts the validity of the experiment, allowing others to trust and replicate the findings. There are several types of controls that scientists use to ensure their experiments are valid. Control group. This is a group in the experiment that does not receive the experimental treatment and is used as a benchmark to measure how the other tested groups do. Constant variables. These are the elements of the experiment that are kept the same throughout to ensure that the test results are due to the treatment being applied. Negative control. A type of control group that is not exposed to any experimental treatment and is expected not to show any effect. This helps to confirm the experiment setup is capable of producing results. To better grasp this concept, let's look at a simple example. Imagine you're testing the effect of sunlight on plant growth. In this case, the independent variable, what you change, is the amount of sunlight each plant receives. The dependent variable, what you measure, is the growth of the plants. The controlled variables, what you keep the same, include the type of plant, amount of water, soil type, and so on. By only changing the amount of sunlight and keeping everything else constant, any difference in plant growth can be attributed to the sunlight, showcasing experimental control in action. Understanding experimental control is essential for anyone delving into the realm of scientific research or simply looking to enhance their English vocabulary in the field of science. It's a fundamental principle that ensures the reliability and validity of experimental results. We hope this video has shed light on the importance of experimental control and how it operates within scientific studies. Thank you for watching, and stay curious.